Hello friends, today I am very excited to share my knowledge on compressed air system and its energy conservation. Compressors are the utilities which are found in common to all types of sectors like textile, cement, steel, power plant, fertilizers and whatever the type of sectors it may be. So focusing on this topic is very beneficial to all plant maintenance engineers. In this presentation, we will be discussing on how much compressed energy is being used at the point of application, its components of compressed air system, layout of compressed air system, the types of compressors, then how to select the appropriate type of compressors as per your needs. We will be studying volumetric and isothermal efficiency, then how to save energy in compressed air system. We will be discussing on various measures that can be taken in compressed air system. We will be also studying air dryers and types of air dryers along their working. We will be studying how to test the percentage of air leakages in your plant and how to test the compressor air capacity. This shows the Sankey diagram for compressed air system. You can see here that only 10 to 30% of the energy in compressed air system is being utilized at the point of application, which means that about 70 to 90% of the energy is being lost in the form of heat or in the form of friction. So a very huge loss is occurring here. So this is the least efficient utility among all type of utilities in any industry. So focusing on conserving energy in compressed air system will be very much beneficial to you in terms of energy as well as in terms of money. These are the components of compressed air system. Intake air filters is the first part that will come in compressed air system. This is the component that intakes the atmospheric air that is fed to the compressor. Interstage coolers are the components which are used to cool the compressed air. After coolers are the components which are used to remove the moisture from the compressed air. People usually confuse between interstage coolers and after coolers. Although both interstage coolers and after coolers reduces temperature, the ultimate goal of these components is different because interstage coolers are used to cool the temperature, whereas after coolers are used to remove the moisture from the compressed air by cooling the compressed air. This is very important to understand. Next comes the air dryers. Even though about 75% of the moisture is removed at after coolers, for some applications like instrumentation and pneumatics, this is not enough. More moisture has to be removed from the compressed air. So air dryers are used where pneumatics and instrumentation applications are used. Then moisture drain traps are also used to remove the moisture in the compressed air system. Receivers are the storage of compressed air system, and it is also used for smoothing the pulsating air output that is coming from the compressors. This is the typical layout of the compressed air system. Here you can see that two compressors are working in parallel and are fed to the receiver through water separator, where the pulsating compressed air output is smoothed and is fed to the ring system via air dryers. In air dryer, we can see oil separator is provided to remove the oil and as well as water from the compressed air system. We will be studying all these parts one by one in this presentation. This is one type of compressor known as reciprocating compressor. This compressor works just like an engine which is there in the automobile. The working principle of this compressor is like this. Whenever the piston comes down, vacuum is created in the cylinder. Because of this vacuum, the inlet air opens up and the atmospheric air enters in the cylinder. When the atmospheric air enters into the cylinder, the piston starts to move upwards and compresses the air. This compression takes place till we get the required amount of compression. As soon as we get the required amount of compression in the cylinder, the outlet valve is opened automatically and the compressed air is fed via this outlet pipe. If you want to see the function of this reciprocating compressor in fast movement, you can see here where the atmospheric air is fed into the cylinder where it is compressed and the compressed air is going out to the outlet pipe. This is the rotary screw compressor. Here the inlet air is fed in between the two types of rotors which are aligned in opposite direction so that they are rotating in opposite direction. Air is fed in between these two rotors, and when that air is fed in between these two rotors, that air is shrinked, and that shrinked means compressed. That compressed air is fed from the outlet here. The output of this compressor is smoother than reciprocating compressors. In reciprocating compressors, we get very pulsating output because of the piston movement. Here, since piston is not there, compressed air output is got only through two rotors rotation. The output air is not that much pulsating. This is the rotary vane compressor. Here, one thing what you have to point is that the outlet pipe will always be smaller than the inlet pipe. So the atmospheric air enters from this inlet pipe and it is fed in between the veins of a drum. This is a drum rotating here, and air is trapped here in this section. And when this is rotated, and here it is fed to the outlet pipe. Here the compression takes place. Next we will see the centrifugal compressor. The working of the centrifugal compressor is very simple. Air is fed at the center of the pillar, and this it is rotated in very high speed. Air is forced outward by centrifugal force, and the diffuser stops the air here, and because of this stoppage the air velocity is reduced, and this air velocity is converted to high pressure, and the high pressured air, that means the compressed air, is fed from the outlet of the centrifugal compressors. So now we have understood the four types of compressors, which are reciprocating compressors, then screw compressors, rotary vane compressors, then centrifugal compressors. Now, as per your needs, the question arises which type of compressors you want. So this is the table which gives you an idea for selecting the type of compressors that you need. Here in this table, you can see that a reciprocating single or two-stage compressor works from 100 cubic meter per hour to 12,000 cubic meter per hour at a pressure 0.8 to 12 bar. So if your working condition is this much, you can go for single or two stage reciprocating compressor. You can even buy this single stage screw compressors also if your working condition is about 1500 meter cube per hour. But going for reciprocating compressor is quite beneficial to you because its efficiency is higher than other types of compressors, but other parameters are also there which has to be taken into account. So this is the term which we have to understand, that is the volumetric efficiency. See, a volumetric efficiency in vague definition, I can simply tell you that output volume divided by input volume. If the output volume is equal to input volume in any compressor, then it is 100% efficient. But actually in practice, the output volume of air in any compressor will not be equal to the input volume. There are a lot of parameters associated with this, why this output volume will not be equal to the input volume. Output volume will always be lesser than input volume because of heat or any friction and other types of losses. That is an volumetric efficiency. Now, isothermal efficiency. To understand this term isothermal efficiency, first you need to know what is isothermal compression. Just like what we studied in the last slide, that if inlet volume equals to outlet volume, then its volumetric efficiency is 100%. Here also the same thing applies. If the inlet temperature of air is equal to the outlet temperature of the air, then it is known as 100% isothermal efficient compression, or it is also known as isothermal compression, or it is also known as perfect cooling. Just like a volume going lesser in the output, here also the temperature will not be lower in the output. The output temperature will always be lesser in the output temperature will always be higher at the outlet. Isothermal efficiency definition is like this. It is the ratio of power required to compress the air isothermally to the power consumed by the compressor. Now we will be looking at the various types of energy conservation measures that can be implemented for this utility. The first one is efficacy of inter and after coolers. As we have studied in earlier slide that the outlet air temperature will always be higher than the inlet air temperature. We have to implement intercoolers between successive stages of a multi-stage compressor to reduce the temperature of the compressed air. If we reduce the temperature of the compressed air, then the work of compression, that means the power requirement to compress that air, will also be reduced, because when we cool the air, its volume also reduces. As the volume reduces, the compressor power consumption also reduces, because it needs to compress lower volume of air. So we have to focus on efficacy of these inter and after coolers. For illustration, I have shown here the reciprocating compressor. This is the perfect cooling taken as a base value. Perfect cooling means for inlet and outlet both should be equal. So here you can see that both inlet and outlet are equal. Here inlet is 21 and outlet is 26, means output is higher. Here inlet is 21 and this is outlet is lower than the inlet. Here we have provided very high cooling. When we provide very high cooling, the capacity in cubic meter per minute, that flow rate, increases, and shaft power decreases, specific energy consumption decreases, percentage of change also decreases. So we have to give more cooling to the compressors. Cool air intake. We have to try to take cool air from the atmosphere, because as I told you earlier that cool air has less volume compared to hot air. As a thumb rule, every 4 degrees centigrade rise in inlet air temperature results in higher energy consumption by 1% to achieve equivalent output. We have to take dust-free air intake. As we have studied earlier that compressed air flows in different types of components like intercoolers, aftercoolers, air dryers, moisture drain traps, etc. If dust is present in the air, that dust also along with the compressed air passes this equipment and chokes this equipment. So we have to take dust-free air intake. For this, we have to fix proper air filters at air intake. We have to also focus that air filter pressure drop should not be high. If there is a 250 mm water column pressure drop, then 2% power consumption will be increased. To know how the pressure is getting dropped, we have to fix manometers before and after the air filters to watch the pressure drops. Okay, now dry air intake is there. You have to take dry air because in compressed air system we will be draining oil moisture from the compressed air system. So work on that components will be reduced if we take dry air intake. And elevation, you know that the pressure is reduced when we go higher and higher above the ground level, and the pressure is increased when we go below or near to the ground level. Because of this, we should focus mainly to take the air from near to the ground level. That means elevation should not be high because compression ratio increases if we take air from high altitude. Cooling water circuit. We have seen that in compressors, intercoolers and aftercoolers are provided to cool the compressed air, and heat from these compressed air are collected by these intercoolers and aftercoolers, and that water, hot water, is again cooled in cooling tower, and fed back to the compressors to once again cool the compressor. Like this cooling water circuit takes place in the compressed air system. We have to focus also on water treatment because if we do not take proper water treatment, then there is a chance of getting total dissolved solids in the cooling water, which will lead to scale formation in heat exchangers. So these scales not only act as insulators in reducing the heat transfer but also increases the pressure drop in cooling a water pumping system. Pressure settings. Compressors should not be made to operate above their unload pressure settings. Usually all the compressors are operated between two pressure settings known as cut-in pressure and cut-out pressure. Cut-in pressure is also known as loading pressure and cut-out pressure is also known as loading pressure. Whenever the compressor reaches the cut-out pressure, then the load on the at that pressure will be cutted out. And whenever the pressure reaches the cut-in point, that is the lower point, the power on it is again applied. So loading and unloading is done using pressure switch. That pressure switch settings should be checked. This is a very important aspect of the compressor, which is known as compressor modulation. If there are many types of compressors in industry, so these compressors should be operated in such a way that the maximum energy efficiency is possible from among these group of compressors. So let us take one case that if there are same type of compressors working, then we have to handle or we have to operate all these compressors in such a way that only one compressor should handle the load variations, keeping other compressors as a base load. Then in case 2, let us take that if there are same type of compressors but having different sizes, in such situation we have to make the smallest compressor to handle the load variation. If there are different types of compressors and different sizes of compressors, then we have to see this table. In this table I have given the efficiency of all types of compressors at different loads. See, in this table you can see that the efficiency of a reciprocating compressor even at no load is high. So making this reciprocating compressor as a load varying compressor is a good decision. If you don't have reciprocating compressor, then you can choose centrifugal compressors because only 20 to 30% of the full load power is consumed here during no load. So see, all these things depends upon the other parameters also, like your working conditions and all. For this you need to get energy audit done from energy auditors. Then segregating low and high pressure air requirements. In any industry, if you need two two types of pressure requirements, for example, say we need a 7 bar for one section and we need 3 bar at another section, then we can take another compressor to work for the lower pressure requirement. This will be helpful to us in conserving energy. Usually, I have seen that in many plants, people use pressure reducing valves. This will really waste energy. Minimum pressure drop in airlines. Check your pressure drop in all the sections, and this is the pressure drop limits as per BEE. zero point 0.3 bar in main setter and zero point 0.5 bar in distribution system. This is acceptable pressure drop. If it is going more than this, then you have to get it checked up from us. Lowers in place of compressed air system. Sometimes compressed air is utilized where blowers can be used for applications such as agitation, pneumatic conveying, or combustion air. This is one of the important equipment known as compressed air amplifier, which are being used nowadays in most of the industries. The working principle of this compressed air amplifier is like this. Only small amount of compressed air is fed from this point. This is known as the Coanda profile, and the atmospheric air is sucked from this point B, and compressed air is amplified here when mixing with atmospheric air. And further, that amplified compressed air is once again amplified at point D by taking the nearby atmospheric air, which is will be present at point C. To install these compressed air amplifier, you can contact us. So capacity control of compressors. In many industries, the requirement of compressed air will be intermittent. For such conditions, we can go for these four types of measures, that is automatic on off control, then load and unload, multi-step control, then throttling control. Even speed control is also there, which I have considered in throttling control. Then air leaks and energy waste. I have seen the major opportunity in arresting the air leakage, so you have to concentrate more on avoiding air leakages. Take air audits occasionally, and during plant shutdown, switch on your compressors and test the air leakages with the help of ultrasonic air leak detector. This ultrasonic air leak detector will help you to find the points where compressed air leakages are occurring. And during shutdown, you can take this test for finding the percentage of leakage of your whole plant. Just start the compressor by switching off all the equipments which are run by the compressed air system. Then note down the load and unload times, and by putting the values in this formula you can find the percentage of leakage. Once you find the percentage of leakage, you can also find the percentage leakage quantity in meter cube per minute. I have seen that in many industries compressors are oversized. which means that usually for small requirements they are using very big compressors, and only during for small time period they use full capacity. This is actually not recommended because during underloaded condition of the compressor it usually draws very high power, and because of this we have recommended them to use VFDs or changing the pulley to match the RPM, that is speed of the compressor, as per their requirements. This will also save their energy. And we can also go for decentralized compressors when the full capacity utilization is not being done. Now coming to the air dryers, in the components we have discussed in brief about this. After coolers also dries air by removing the water droplets from the compressed air, but only 75% of the water droplets are removed in after coolers. Remaining 25% should also be removed for applications such as instrumentation and pneumatics. The performance of dryer is quoted in terms of pressure dew point. For example, the pressure dew point is 3 degrees centigrade at 7 bar, means that below 3 degrees centigrade at 7 bar only the water will condense. Above that it will not get condensed. There are two types of air dryers. One is the refrigerant air dryer. As I have told you that the dew point is required for any dryer, and here the dew point is achieved by using HVAC systems. This HVAC system I will be discussing in another video, but as of now we will be understanding only how that air is dried by chilling. The compressed air is cooled to below 3 degrees centigrade, and the water droplets are taken out from from the draining point. Here is the wet air coming inside, and where it is cooled here, waters and oil are drained here. Sorry, the water and oil is coming here, and it is drained here, and compressed dry output air is coming out from here. One more important aspect in this air dryer is that the heat exchanger is provided to pre-cool the incoming compressed air. So here wet air is coming here. This is cooled from the dry air out. This dry air will be so cold that it can reduce some temperature of wet inlet air that is coming into this dryer. This will reduce some energy. The pressure loss in this type of dryer is approximately 0.2 bars. Now heat of compression is one type of air dryer where no electrical energy is being used. Here the air is made to flow from here, and here adsorption takes place in this bed, and part of the compressed air is made to flow to desiccant bed B, and remaining air is dried and it is made to flow from the outlet of this air dryer. Here you can see that after adsorbing of desiccant A, it stops adsorbing the compressed air, and next the B starts working when the till the its maximum capacity. When this capacity is reached, maximum capacity is reached, again the A bed will start working. You can see here once again, air it is getting adsorbed and dried air. Air is coming out here, dried air. It is reaching its maximum potential of adsorption. After it reaches maximum adsorption, the moisture is exhausted from here till total bed is getting dried. During this time the bee starts working, and again this A bed starts regenerating by taking a small amount of compressed air from this bed. Like this the cycle continues in this type of dryer. This is very energy saving dryer. Then coming to the compressor capacity, this is the testing procedure. Isolate the compressor along with its individual receiver by closing the receiver outlet. Drain out the water from the receiver and pipeline and close the drain valve. Start the compressor and activate the stopwatch. Note the time taken to attain the normal operational pressure P2 from initial pressure P1. And after noting down all these parameters, just put the values in this equation and you will finally get the value in meter cube per minute. So I thank you all for watching my presentation, and I hope you had taken some knowledge from me. Apart from this, if any feedback to be given on this presentation, you are always free to give feedback. Thank you all. And lastly, please don't forget to subscribe my channel so that I'll be uploading other videos, and share this video so others can also be benefited from my presentation. Thank you.